All right. Okay. Okay, let's go over the second lesson of thermochemistry. We're going to learn how to measure calories and change in heat. So by the end of the day, I want us to be able, or lesson, I want us to be able to describe what the function of a calorie meter is and explain what temperature change is dependent on and explain specific heat and use the specific heat equation, okay? Um, so we're going to first learn about the measuring calories using the device a calorie meter. So it is the measurement of heat change in a chemical and physical process. So this is how scientists find out how many calories are in your food, and they find out how much temperature change was in a reaction. But we do it more accurately and precisely than just sticking a thermometer in a beaker. So we're going to learn about the devices that we will use to measure the amount of heat that is absorbed or released during the process, okay? So yes, we will use styrofoam cups. If I can find some, I haven't seen any in Greece, but maybe I'm missing it. I'm not sure. If I find some, we will use these to do a lab. Um, we're not going to do this unit for a couple of months, actually, from the time I'm recording this. So, anyways, in the U.S., we used coffee cups, a coffee cup calorie meter, where to measure the chemical reactions, it's at constant pressure, and that constant pressure is actually our atmosphere. Okay, there's no pressurized anything. This is just like a lid or a cover, and then you have your thermometer. So this is very simple. This is something you might be exposed to in your university if you were to go take a chemistry class, and they kind of show you this. If you were to go a little further into chemistry, you might use a bomb calorie meter, which doesn't mean like a cool calorie meter. It means like there's actual little fire inside and you're igniting it. So this one is how we measure the calories in a food or something, or when something is burned, and we will measure how much the temperature change was, and this is the device that we would use it. It's actually closed, pressurized, it's dry in there, there's a fire going, there is oxygen being fed in and out of it on some devices, and that feeds the fire. And we measure the temperature that increases while the fire goes, and then we plug it into the equation that I will show you in just a minute. So, temperature change is dependent on three things, okay? So, the amount of heat we add, okay? The mass of the substances and what the substances are made out of, okay? Because what the substances are made out of, it'll have a different specific heat. So, for example, the specific heat is just how much heat required to raise 1 gram of a substance by 1 degree. So it'll be a different specific heat for water than it would be, say, for hydrochloric acid. So these are the units for specific heat. It's just calories or joules per gram degrees Celsius. And the specific heat of water is 1 calorie, okay, per gram degrees Celsius. Or we can also use joules depending on what the equation's giving us. You'll see in a minute what parts of the equation we're talking about. Okay, so here's our specific heat equation, or heat transfer equation. We're going to look at each of the, let me get it all in here. Okay, so the Q will stand for heat. I told you guys that yesterday, and that's whatever the problem will give you. It might give you joules, it might give you calories. And then the mass is just mass in grams. Specific heat, usually you'll be given that unless you're trying to find it out. Then you'll have the other variables to find it out. And that can be in calories or joules as well. Just make sure that whatever this is in, this is in. So it's easier to change this into joules or calories. So if the question gives you this unit, make sure you put it in the heat in this unit. You might have to do a dimensional analysis conversion. And change in temperature is just the ending temperature minus the initial temperature. And make sure it's in degrees Celsius. That's important because it's degrees Celsius here. So because specific heat are these units, make sure your units align as well, or else it's not going to come up with the right answer. All right, so our first example, how many calories of heat are required to raise the temperatures of 525 grams of aluminum from 13 degrees Celsius to 47.8 degrees Celsius? And they give us the specific heat of aluminum, which is this. So we're in calories per grams degrees Celsius. So calories, did it give us calories? It's asking for calories. So we're trying to find Q, okay? And grams, we have grams, Celsius, we have Celsius. We do have to subtract this, but we're good with our units. So we're just going to plug in our variables and basically do a quick calculation. So Q, it's asking for how many calories. That's our Q, okay? How much heat, calories of heat are required. M, we have our mass here. It gives us our C right here, okay? So we plug that in. And it gives our temperature change. So it's temperature change. That triangle means a change in something. So make sure you know that you need to subtract 47 minus 13, and that's your actual number you're going to plug in. So Q will be, so remember that Q, it was M times C times change in temperature. So you will take them and multiply them all together. Your grams will cancel, your degrees Celsius will cancel, and you'll be left with your unit of calories, and that would be your answer. Next question is what mass of water. So we're actually trying to find M now. We're going to be given a Q, we'll be given a C, we'll be given a change in temperature, which we're not actually given a C in this question, but we do know that the C of water, remember, it's calories, so we're using the unit calories. So the C of water would be 1 calorie per gram Celsius, okay? So Q, it tells us change in temperature, so we need to actually, the heat will be 5.1 kilocalories. We can't use kilocalories, and that's because, okay, we don't have it in our, we're trying to, the C is 1 calorie. So you need to make sure to convert that to calories. So just do quick dimensional analysis. 1 kilocalorie equals 1,000 calories. So that's actually how many calories we have. Our mass will be what our unknown is, what mass of water, so that's our question mark. Our change in temperature, we just take 94.1 minus 22.5 and we have it. And then remember, C is something we should just know, which is 1 calorie per gram degrees Celsius. So our units are good, and we're just going to plug it in here. So our Q equals M times your C times the T. So your calories will cancel, your Celsius degrees will cancel, and then we'll just be left with the correct unit, mass. And once you plug it all into your calculator, you have your answer. Okay, let's do number 3 of the homework on the homework packet. What is the mass of a sample of alcohol with this specific heat if it requires this many joules of heat to raise the temperature by this many degrees? So remember, if you'll remember, the variables in the problem or the equation are heat, okay, Q, mass, specific heat, and the change in temperature, so delta T. All right, so the heat, the change in heat, I'm sorry, not heat, the joules, okay, the heat in joules is here, okay? So 4,780 joules, okay? And the mass of a sample is, the mass is the question that they're asking. So that's our actual variable. How many grams, okay, of alcohol. And then specific heat is C, so that's this one. Why did I do that? Okay, joules per grams per degree Celsius. Okay, erasers. All right, and then the delta T says heat raised the temperature by this many degrees. So that's the change in temperature. Sometimes you'll have to subtract it like here. You would have to subtract 20.4 minus 10, but it actually gave you the change in temperature, so you don't have to do that part. So 5.43 degrees Celsius. So I always like to just quickly check if my units are correct. So we have joules here, grams and grams, and degrees Celsius, so we're okay. You would get the wrong answer if they had given it to you in calories and you just plugged everything in, because you would have had to convert to calories first. Okay, so the equation is Q equals MC delta T. So we're just going to plug stuff in. So that would be 4,780 equals, we don't know the mass, times 2.4 times 5.43. Okay, so we want to get mass by itself, right? So we're just going to divide by 2.4. And you could have multiplied these two together if you wanted to. This is just how I'm going to do it. And then that would give us m equals something. So we'll just go ahead and take this divided by this times this. Plug it in the calculator. So we'll take 4780 divided by parentheses 2.4 times 5.43 equals. We have significant figure wise we can only use 2, so we'll do 370. So 370 would be our 370, and the other units will cancel out, and so that would be 370 grams.